In the next two parts, we will go into data types in Java. We distinguish here between primitive data types and non-primitive data types. However, in this part, we are dealing with the primitive data types first of all. A basic understanding of the primitive data types is necessary because the whole programming is based on them. In Java, you have a few things to pay attention to here. But let's start outside of Java and refresh our knowledge about the data type which is responsible for everything else. If you don't know what a byte or a bit is, this part is especially important for you. A byte is only a combination of 8 bits, and a bit is only the values 0 or 1, so no power or power. To get larger numbers now, the bit is always representing double the size of the bit before. So we get a range between 0 and 255. The problem with this is that we can only store positive values. To also store negative values, most programming languages uses the two's complement. Here, the first bit in our data type gets used for defining if it's negative or positive. 0 stands for a positive data, and 1 stands for a negative data. So with this, we lost the first bit in our byte and our range changes. The min value is no longer 0. It is minus 128. And our maximum value is now 127. Since we yet know how to create larger numbers, let's look at some examples. First of all, we change the third bit from the left, and we get the decimal number 4. Then we change the 6th bit in our byte and get the decimal number 36. Now we want to get in the negative range, so we are changing the first bit and get the decimal minus 92. We are also changing the second bit and get the decimal minus 28. This happens because in the two's complement, every bit after the first bit is always positive. So if we change the second bit of 64, we are incrementing our number and not making it smaller. So now let's get some information about other data types such as short, integer, float, long, and double. The byte we already learned has 8 bits. The short has 16 bits, integer and float have 32 bits, and long and double have 64 bits. We already know the length of a byte. Here you can see the length of a short too. The actual minimum and maximum values for integer and float and long and double are too big to represent them in this video. So we are just looking at why they are different, since they still have the same bit sizes. So let's take a look at integer and long first of all. Integer and long are more limited than float and double and can have smaller values. Also, they cannot store floating points, so only full numbers can be stored in integer and long. Float and double can store floating points, but we have some precision loss in the actual number due to they are created with logarithm calculation. And due to the calculation, they are a little bit slower than int and long. So now we have two other data types missing, the boolean and the char. The boolean is a value between 0 and 1, so he has only 1 bit, and the char has 16 bit. These bits are only in the positive range, so the char don't use the two's complement. This is because the char has only character values for some numbers and therefore can represent text in our applications. The boolean is for conditions like true or false. False for 0 and true for 1. So now let us have a look in our IDE at some primitive data types. In our IDE, we first of all create a byte b with the value 127 in our main method. We also test to increase this value, but our IDE is already marking it for not possible. We also look at the minimum value and can see we can't go further there. After this, we create a short variable and assign the byte variable to it. That's possible because a short is always bigger than a byte. Then we create an int variable and assign a short variable to it. Also there, the int is bigger, and the same with long. So now let us print these variables. For this, Java provides the system.out.println method. This method prints the desired data with a line break, so the next system out will get printed in the next line. We are passing our variables to these methods. After this, we have the run buttons in IntelliJ green on your left side of the file. You can click on them and click run main.main. Then IntelliJ runs your application. In our console output, we could see we got the value printed for every method. After this, let's get into the floating types. First of all, we are having a look at the double and assigning L to this double. That's possible because a double can always also store a long value. We system out println this double too. Then we create a float f and assign the integer value to it. That's possible because float can store an integer always. Also, this float we are printing to the console. So let's run the application again. We can see the floating points are marked with a dot and a 0 behind it. So you can see they have floating point values. If we now create a new system out and write some data directly into it, we can choose which data we are writing. With a dot in our data type, it's always a floating point. With a D or an F behind our data, we can set if it's a float or a double. So let's take a look at the precision loss we talked about. For this, we are dividing our value. If we now run our application, our system out println has very accurate decimal places. If we change the data type to floats and run it again, we can see there are less decimal places and the number is less precise. If we now cast the value to a double, we can see that there is a precision loss. And that's it for this part. In the next part, we will go into non-primitive data types. So, see you there.